In this lesson, we're going to talk about equation applications. So these are real-life situations where you might encounter an equation and have to solve for it. Let's go ahead and look at a couple examples. The first question says, Anne took a taxi home from the airport. The taxi fare was $2.10 per mile, and she gave the driver a tip of $5. Anne paid a total of $49.10. Now, there is something missing from this question, or this problem, and it's the question, how many miles did she travel? So I'm going to go ahead and then write that up here. That should be at the end of this problem. My apologies with that. So the question is, how many miles did she travel? Let's go ahead and see if we can construct an equation here. So Anne took a taxi home from the airport. That is important information to know because it gives us situational information. Now, the taxi fare was $2.10 per mile. So aren't we looking for how many miles? Well, if it says per mile, that means that we have an unknown in this problem. So let's go ahead and set it up like this. $2.10 times our unknown of $2.10 per mile. She also gave the driver a tip of $5. So we're going to go ahead and say we're going to add $5 to that amount because that's how much she's going to be paying. And then we're going to set that equal to her total, which is $49.10. Now, let's just kind of look at that equation for a second. So we know that Anne's going to pay $49.10, but what is she going to be spending her money on? Well, she's going to be spending it on each mile she's going to spend $2.10, and she's also going to tip the taxi driver for $5. So we just constructed a two-step equation. Now let's go ahead and solve it. So I'm going to go ahead here and I'm going to rewrite my problem. And we're going to go ahead and use our skills of solving equations to solve this problem. I'm going to begin, I'm going to actually change my pen color here, and I'm going to begin by putting a box around my variable, and I'm going to draw a line down my paper. I'm going to begin by subtracting 5 from both sides. And that's going to leave me with $2.10 times x. My 5s are going to cancel out. I'm going to bring down my equal sign. And now $49.10 minus 5, that's going to leave me with $44, or 44.1 or $44.10, either one you want to write. But you can see here that I'm not done. I do have to box my variable again, and I have to divide both sides by $2.10. That's going to finish off my problem now. I can see that my $2.10 cancel out, and I'm left with x is equal to 21. Now, you can see this little thing off to the right-hand side, these three little dots. This means therefore. This is kind of like recapping or restating your problem. So the question was, how many miles did she travel? So what we want to do here is say, therefore, Anne traveled 21 miles. You can also be more explicit. You could say Anne traveled 21 miles home from the airport if you like, but this will suffice. All right, let's go ahead and look at another example. All right, in example number 2, it says, Sam had $276 to spend on 7 books. After buying them, he had $17. How much did each book cost? So we know that the question being asked is, how much did each book cost? So that's going to be our variable, the cost of the books. So let's see if we can construct an equation. We know that Sam started with $276. Let's start there. And he spent his money on 7 books. So spending money means that the money's going to go away. So we're going to go ahead and subtract 7. And not only are we going to subtract 7, but remember, the variable that we're going to be using is representing books. So we're going to say minus 7 books. At the end of the day, he has $17 left. So, equals 17. All right, let's go ahead and take our equation and let's go ahead and solve for the variable. I'm going to go ahead and change my pen color real quick. Let's go ahead and put a box around the variable and draw my line down my page. I'm going to start here by subtracting 276. Kind of a big number. We haven't really been working with big numbers like this, but feel free to use your calculators. My 276's are going to cancel out, and I'm left with negative 7x is equal to. So 17 minus 276 is going to leave me with negative 259. But that's not quite my answer yet. I have to continue. So I'm going to go ahead and put a box around my variable, and I'm going to divide both sides by that number that's bothering the variable, negative 7. Negative 7 are going to cancel out, and I'm going to be left with x is equal to 37. Now, let's go to the therefore statement. It said, how much did each book cost? Well, our answer is going to be 37. So let's go ahead and recap. We could say that each book cost $37. And we're done. All right. I think I have one more. No, I have two more here for you. Let's try another one with a piggy bank. Bethany spent half of her weekly allowance playing mini golf. To earn more money, her parents let her wash the car for $4. What is her weekly allowance if she ended with $12? All right, so Bethany, she spent half of her weekly allowance playing mini golf. Well, how do we represent that? Well, a half we can represent by writing actually 1/2, right? Now, let's just kind of reflect on what we're being asked. It says, what is her weekly allowance? What's her weekly allowance going to be? Well, if the question states Bethany spent half of her weekly allowance, well, can't we say that that's going to be our variable? So half of x, our weekly allowance. So she's going to spend half of that. But her parents also let her wash the car for $4, meaning that she's gaining money. She's earning money, which means that we're going to add $4 to a half x. And then at the very end of the problem, it says she ended with $12, meaning after all is said and done, she is going to have $12 in her piggy bank. So here's our equation. Let's go ahead and solve. I'm going to start by putting a box around my variable and drawing my line. I'm going to eliminate positive 4 by subtracting 4 from both sides first. That's going to leave me with 1/2 x is equal to 8. Now I'm not quite done. I do need to box my variable, and I'm going to eliminate the 2 here. So I'm going to multiply both sides by 2 to get rid of my denominator. And that's going to leave me with 1x. Now 1x can also be written just as x, and that's going to equal 16. So x is equal to 16 is our answer. So the question being asked again is, what's her weekly allowance? Well, her weekly allowance is $16. All right, last one. Let's go ahead and look at this one. Tom bought a soft drink for $4 and 6 candy bars. He spent a total of $28. How much did each candy bar cost? So the question being asked is, how much did each candy bar cost? That's going to be our variable. We could even say that that's going to be called x. Let's see if we can construct this problem now. So Tom bought a soft drink for $4. All right, so $4. And he also bought 6 candy bars. But do we know how much the candy bars cost? No, we don't. We just know that he bought 6 of them. So let's call it 6x. He spent a total of $28. So I'm going to set that equal to 28. Now let's go ahead and solve to see how much each candy bar is going to cost. All right, I'm going to go ahead by putting a box around my variable and drawing a line down my page to separate my equation. And I'm going to subtract 4 on both sides first. 4 minus 4 is 0, leaving me with 6x is equal to 24. But I'm not quite done. I have to put a box around my variable again. And this time, I'm going to divide both sides by 6. My 6's are going to eliminate. X is equal to 4. So the question is, how much did each candy bar cost? Well, each candy bar cost $4. And we're done. All right, so those are 4 really good application problems of using equations. Now let's go ahead and let's actually look at an equation a different way. This is kind of unique. The question being stated is, which number is the solution to the following equation? So we talked about this a little bit in the previous sections, but we want to figure out which one of these numbers is going to be the answer. And if you remember, we talked about one side of the equal sign being equal to the other side of the equal sign. So what we can do here is we can actually try this using all 3 of these numbers. Let me show you what I mean. I'm going to take each one of these numbers and substitute it into the variable x. Let's go ahead and do the first one. It says -2, and what I'm going to do is I'm going to substitute the number 3 into the variable x. And we're just going to go ahead and solve it out. All right, that's going to be -6 minus 7 is equal to 9. All right. Now, if you think about this, -6 minus 7, well, that's going to give us -13 equals 9, which is not true. And this is how you say that an equation is, the statement is not true. So 3 cannot be a solution to this equation. Let's go ahead and try -1. I'm going to do the same thing. I'm going to go ahead and substitute -1 in there. So -2 times -1 is going to give us 2, minus 7 is equal to 9. 2 minus 7 is going to equal -5. You can see that -5 does not equal 9. So therefore, sorry about that. -5 and -9, or -5 and 9 are not equivalent, and therefore -1 is not our answer. Now, just to be sure, let's go ahead and test -8. I'm going to go ahead and substitute -8 into my variable. And I'm going to go ahead and solve it. I have 16 minus 7 is equal to 9, using my order of operations. 16 minus 7 is equal to 9, and therefore 9 is equal to 9. So you can see that 9 is not my answer, but -8 is the solution to this equation. So this is the number that I can substitute in for x for the left side of the equation to be equal to the right side of the equation. So it's the only solution that will satisfy this equation. All right, I've got 3 more similar types of questions here. Let's see what we can do. Feel free to pause the video if you'd like to try these on your own. Determine if the given number is the solution to the equation. So we want to know, is this the solution to this equation? And the only way to figure it out is to substitute it in for the variable. So you can see that my variable in the first one is a. So I'm going to go ahead and substitute 7 in for the a. All right, so 6 is equal to -8 plus 2 times 7. So that's going to leave us with 6 is equal to -8, and then 2 times 7 is going to be positive 14. All right. Let's see if -8 plus 14, if we get that, that's going to equal 6. So 6 is equal to 6, which satisfies this equation. So that means 7 is going to be the only number that you can plug in for a to get the left side of the equation equal to the right. Let's try the second one. Let's go ahead and we're going to be plugging -8 into our variable. So I'm just going to go ahead and I'm just going to rewrite everything. I'm going to put negative 8 up top. And you can even put them in parentheses if you like. Now I'm going to do the problem here. So I have negative 8. And if you look at here, I have negative 8 divided by 4. Well, negative 8 divided by 4 is negative 4. So I'm going to go ahead and write minus 4. And there's a plus there too, but remember, when you have a plus and a minus next to each other, it always turns into a negative, or a minus. Equals negative 10. Negative 8 minus 4, that's going to be negative 12. Which you can see here is not going to be equal to negative 10. And therefore, negative 8 is not going to be the answer to this equation. And the last one. Let's go ahead and we're going to put 19 in for our variable. So we have 19 minus 1 divided by 6 is equal to 2. So let's go ahead and solve it. I'm going to go ahead and do the top. 19 minus 1 is 18. So we have 18 divided by 6 is equal to 2. And if I divide 18 divided by 6, it's actually going to give me 3. So 3 is obviously not going to be equal to 2. So 19 is not going to be the answer to and the solution to this equation. So that's a great way to check yourself to make sure that your solution that you've got is actually indeed the answer and the only answer that satisfies the equation. All right, that brings us to the end of our section on applications of equations.